All right, we'll continue with our exam review. We're going to look at first some questions from Chapter 7. I have a couple of exponential equations here for you. Now, the idea with an exponential equation, when you're trying to solve for an unknown that is in an exponent, is you have to get a common base. Before I get a common base with this one, what could I do with this plus 7? I could subtract 7 from both sides. It would leave 2 raised to the power of 2x plus 2 equals, what's 71 minus 7? 64. And then from there, I want to get a common base. What's the base on the left? So 2, what's the base on the right? 64, what's a good base to use? Anyone have an idea? 2, okay? I can change this to a base of 2. It's really 2 to the 6th. Okay, now, some people just know that. They know that 2 to the power of 6 is 64. If you don't know that, what could you do? What could I do to go from here to here? I could take the log, the common log of 64 and divide it by the common log of 2. You could do the natural log of 64 divided by the natural log of 2. And that would leave a 6. I don't just write 6. 64 doesn't equal 6. You have to write base 2 to the exponent of 6. And then what do? Once you have a single base on the left and a single base on the right, you can drop the base and just compare the exponents by setting them equal to one another. Once again, to solve for x, I will subtract 2 from both sides, or move the positive 2 from the left to the right and make it a negative 2. 2x plus 2 minus 2 would leave 2x. 6 minus 2 would leave a 4. And then what would I do from there? Divide both sides by 2 and I get x equals 2. What should I do at this point? I should test that answer. So I go back to the original question. And I'm going to fill 2 in for x. If I fill a 2 in there, 2 2s are 4. 4 plus 2 is 6. I'd have 2 to the power of 6 plus 7 equals 71. 2 to the power of 6 is 64 plus 7. 71 equals 71. What does that say about x equals 2? It is a solution, or it's an extraneous solution, or it's not a solution. It's a solution. X equals 2 is a solution. Another example over here. It's a little more complicated. It gets us to use our exponent laws a little more. We've got 9 to the power of 2x plus 1 equals 81 times 27 to the power of x. Anyone know what the base I should use is? 3. Awesome, Colin. Thanks. Now, again, does anyone know what 9 could be, how I could write 9 with a base of 3? It's 3 squared. The 2x plus 1 isn't going anywhere. Your equal sign isn't going anywhere. What about the 81? 3 to the power of what equals 81? 4. Good job. 3 to the power of 4. And that's multiplied by, what's 27? 3 to the power of what? 3. Again, if you didn't know how to do that, or if you couldn't solve it in your head, you could do the log of 9 divided by the log of 3. That would equal 2. You could do the log of 81 divided by the log of 3. That would give you 4. And you could do the log, or the natural log, of 27 divided by the log of 3. and that would equal 3. And I write base 3 to the exponent 2, base 3 to the exponent 4, base 3 to the exponent 3. Now, before I get into dropping the base, let's use our exponent laws and try and get a single power on the left and a single power on the right. Everyone okay with this move? When you raise a power to a power, you multiply the exponents. What would be the exponent on this 3? What's 2 times 2x? And 2 times 1. Everyone okay with that? It's going to equal 3 to the 4th times 3 to the 3x. Same rule. When you raise a power to a power, you multiply the exponents. What do I do with these? What's the rule when you multiply powers with the same base? Like I said to you, what's x squared times x to the 5th? Yeah, you write your base down again, you add the exponents, and you get 7. So in my situation, I have 3 to the 4th times 3 to the 3x. I'll write the base down, 3, and I'll add those exponents, 4 plus 3x. It doesn't give me 7x, okay? A lot of people would write it like this. But I can't add those exponents any further because they're not like terms. I left with 3 to the power of 3x plus 4. And the rest of the, it's like from this step down, look, I have a single power on the left and a single power on the right. I can get rid of those. I can take the 4x plus 2, and I can set it equal to the 3x plus 4. Sometimes you end up with x squareds, like you might have a quadratic here. You might have to factor, group your like terms and factor, or bring everything one side, set it equal to 0, and then factor it, or use the quadratic equation. In this case, it's just a matter of grouping my like terms. Everyone okay with that line? So I brought the 3x from the right to the left, and I brought the plus 2 from the left to the right. What's 4x minus 3x? 1x. What's 4 minus 2? It's 2. Is it always equal 2? No, it's just a coincidence, right? Then I go back to the original. 9 to the power of 2x plus 1 equals, it was 81 times 27 to the power of x. Yes? That's what the original question said. And here's what we'll do. This becomes 9 to the power of 2 times 2 plus 1. This is going to be 81 times 27 squared. This becomes 9 to the 5th. 2 2s are 4, plus 1 is 5. And then this is 81 times 27 squared is 729. Now, if I multiply that by 81, I've got 59,049. 9 to the power of 5 is also 59,000 to the power, 59,049. What does that mean about x equals 2? It is a solution. Now, if you didn't have a calculator, you could do the following. You could change that to a 3 squared. You could change this to a 3 to the 4th. And 729 is 3 to the 5th. Sorry, 6th. That's 3 to the 10th. Multiply the exponents. That's 3 to the 10th. Add the exponents. Cool? But either way, you would prove that x equals 2 is a solution. All right, flip over. We're going to look at some information from chapter 8. It says rewrite each expression as a single logarithm. So I want to write this all as one logarithm. So it should say log base 5. And then there will be some argument, we'll call it, in brackets. The first thing I want to do is send the coefficients back up as exponents. So this term would become log base 5 x cubed. This term would become log base 5 x minus 1 to the 1/2. And this last term would be log base 5 x squared plus 1. Make sure that when you're writing your logarithms that you put the base, the 5, down near the bottom of the G. Raising something to the power of 1/2 is like doing what? Taking the what of it? Square root. Okay? So you could replace that 1/2 with a square root symbol if you like. But when I go to write this as a single logarithm, here's what I'll do. I'll write log 5. And I can only do this if all of these bases are the same. I can use my product quotient, and I've already undone the power law of logarithms. I'm going to do this. What should go up top? Anything with a plus sign in front of it. So this is a positive logarithm. This is a positive logarithm. So what do I put up top, though? The x cubed and the x minus 1 to the 1/2. Okay. What would go on the bottom? X squared plus 1. And you could write this like so. Log 5, you could call it x cubed times the square root of x minus 1 all over x squared plus 1. Can I do this? Can this knock off 2 of those and make that an x? Yes or no? No, Matthew Caleb, you're right. Why not? Because of that plus sign. That's it. That's all. That's all I can do with it. If this was a minus sign, say that was a positive, this was a minus, this was a minus, the x minus 1 to the 1/2 would go on the bottom and get multiplied by the x squared plus 1. Or it would say x cubed divided by root x minus 1 times x squared plus 1. Those are our laws of logarithms. Chapter 8 is where this came from. Flip over, next one. You get 2 more examples. We've got a logarithmic equation. So this is also from chapter 8. And then we have a word problem, which really you could use chapter 7 methods or chapter 8 methods. But let's do this one. So it says log 10. You may also see that written just like this. If no base is written, it's understood to be a 10. It's called a common logarithm. How can I combine these as one? Think about what you did in the last question. You could write log base 10 or just log. And what would you do with these 2 things? Positive, positive. So what would I do with the x plus 2 and the x minus 1? I'm going to multiply them together. Perfect. You okay with me writing the base in there, even though it's not necessary? All right, I'll work this out. I will multiply. What's x times x? X times negative 1 is negative x. 2 times x is 2x, and 2 times -1 is -2. I'm going to group my like terms in here. -x plus 2x would leave 1x. And then a lot of people think this is the move. They want to subtract 1 from both sides. No good. Anyone remember what the advice was in this unit when you got stuck? Like if you come to a point in a logarithmic equation where you don't really know what to do? Shaking his head? Yeah, switch forms. So what form is it in right now? Log form or logarithmic form. Anyone know what the base is? Base is 10. What's the answer? Yeah, the answer is x squared plus x minus 2. And what's this? That's the exponent. How would you write it? What's the other form? There's log form, and what else did we talk about? Exponential form. How would you write this in exponential form? Look, there's the information that I need to work with. I would write 10 raised to the power of 1, and it equals x squared plus x minus 2. Then I just solve this. What's 10 to the first, guys? Here's the situation which we talked about on the previous slide. Like what happens when there's x squareds and x's? It's not as simple as just collecting like terms and then dividing by something, or what do? Set it equal to 0. So I'm going to move the 10 from the left to the right. I'm going to group my like terms. And then I'm going to factor. It's a simple trinomial. You could also use the quadratic equation, but it's easier to factor. What two numbers add to give 1 and multiply to give -12? Well, think about what multiplies to give -12. It's a 1 times a 12. And the larger factor has to be a positive because you're adding to get a positive. Or a -2 times a 6, or -3 times a 4. What is it? -3 and 4. -3 and +4. These two numbers satisfy both of these. So over here, I'm going to go 0 equals. What do I write in the brackets? X minus 3, x plus 4. Zero product principle tells us that if x minus 3 times x plus 4 equals 0, one of these things has to equal 0. One of the factors. So x could equal 3, or x could equal -4. What do you suppose I'm going to do when I get these two answers? Test them. So what did the original question say? Log x plus 2 and log x minus 1. Equals 1. So I'm going to just clone that and move it over here, and I'll test both of these solutions. So let's start with the 3. Oops. So this would say log 5 plus log 3 minus 1 is 2 equals 1. I could write these as a individual logarithm. I could say log 5 times 2. Five 2s are 10. Remember, the base is 10. That's asking you what exponent. What's the logarithm? That's all a logarithm is an exponent. What's the logarithm you'd raise a base of 10 to get 10 for an answer? Yeah, this is 1, this is 1. You could hit log 10 in your calculator and it would say 1. What does that mean? X equals 3 is what? Is a solution. What if I pull the -4 in here? Not sure why this turned blue on me, but that's all good. What does this work out to be? What's -4 plus 2? And what's -4 minus 1? And we know right away that this is what? A domain error. There is no exponent that I could raise a base of 10 to get -2. Or there's no exponent I could raise a base of 10 to get -5. If you do the log of -2 or the log of -5 in your calculator, if you tried that, it would say error. So what does that mean about x equals -4? It is not a solution, or it's extraneous. Cool? Last question, and then we'll be done with chapter 7 and 8. Don't forget about transforming exponential functions and transforming logarithmic functions. But here is a problem. I would assume that most of you will do it this way. But you got to remember the form that your equation takes. It's the initial amount multiplied by the base raised to the power of x over, and we always wrote the time it takes, and I do this. Depends on if it's doubling, tripling, quadrupling. It has a half-life, a quarter life, something like this. So read the question, 2. This was like a test question. I think this is off your test. You might not have had the same initial amount, but it was a similar setup on your test for chapter 7 and 8. Cobalt 60. 60 is the mass number, which has a half-life of 5.3 years. So the half-life, that's my base. 5.3 years, that's the time it takes. And this is used in medical radiology. A sample of 60 milligrams of material is present today. Write an equation to express the mass of cobalt 60 in milligrams as a function of time, t in years. So y in this case is going to represent your mass, and x is going to represent your time in years. What would my equation look like? What would I fill in for the initial amount? 60 milligrams, that's what I'm starting with. What would I fill in for the base? It's 1/2. You could use 0.5 if you like. Your exponent is going to be x over, what's the time it takes? 5.3 years. Okay? It might make more sense if someone wrote it like this. Mass as a function of time is equal to 60 times 1/2 to the power of t over 5.3. Either is acceptable to me. I don't care if you use y or x or m and t. Just know that when you're solving for the y value, your answer is going to be in milligrams. It's going to be a mass. If you're solving for the x value, your answer is going to be in years. What is this asking me to do? Solve for y or solve for x? Well, what do they give me? $10.6. Is that the mass? Is that the y value? Or is that the number of years? The time. It's the x value. So x equals 10.6. Here we go. Y equals 60 times a half. That 5 point, those numbers don't change. The 60, the 1/2, and the 5.3. I'll put the 10.6 in here. Is it okay for me to do this? Am I okay to say 60 times a half is 30, 10.6 divided by 5.3 is 2? Does that make sense? Looks like it does. Can't, why not? Yeah, I can't multiply the 60 by the 1/2 before doing the exponent. So I end up with 60 times a half, 10.6 divided by 5.3 is 2. And then I would do this. Y equals 60. I'm going to raise a half to the exponent of 2. I'm going to square it. What's a half times a half? A fourth. And then if I multiply 60 over 1 by 1 over 4, I'd get 60 over 4. Or I'd get what? What's 60 divided by 4? 15 milligrams. And I would say 15 milligrams remains after 10.6 years. Cool? So it goes from 60 to 30 to 15 to 7.5 and so on. Every 5.3 years. How long will it take for the amount of cobalt-60 to decay to 12.5% of its initial amount? What was the initial amount? 60. Of means multiply. And what's 12.5% as a decimal? Percent literally means per 100. That's what the 2 zeros represent. That means divide. So divide by 100, 1, 2 spots to the left. I get 0.125. What's 0.125 times 60? 7.5 milligrams is what we're dealing with here. That's the Y value. So in this case, it's Y that equals 7.5 milligrams. Okay, it's saying how long? Solve for X. So go to your equation. Remember the 60 milligrams, the initial amount, the base of 1/2, it has a half-life, and it's every 5.3 years. Those don't change. This time I put the 7.5 in here. What do I do to get rid of the 60? I divide both sides by 60. And 7.5 divided by 60, it's 0.125. And over here, I have 0.5, 1/2 to the power of x over 5.3. You could write it like this. 1/8 equals 1/2 to the x over 5.3. 7.5 over 60 would reduce to 1/8. Most people would probably do this. But what's the move now? I'm trying to solve for an unknown, an x value that's in the exponent. So I should get a common what? Base. What's a good base to use between 0.125 and 0.5? I want to use this base. So I'm not going to change the right-hand side. You might, this is why it's nice to use the fractions. Does anyone know what this would be expressed with a base of 1/2? 2 to the power of what would give you 8? 3. Same thing over here. If you do the log of this number and you divide it by the log of 0.5, you would get 3 as well. Now you have a single power on the left and right. You could say 3 equals x divided by 5.3. Same thing over here. And what would you do to solve for x? How would you get rid of a divide by 5.3? Multiply both sides by 5.3. And 5.3 times 3 is 15.9. 15.9 what? What's the units on the x value? Here's nice. That's the show. That's chapter 7 and 8. Again, don't forget about transforming exponential functions and logarithmic functions. I ripped through exponential equations and logarithmic equations and a word problem. And I reviewed your laws of logarithms. You can take the rest of the period to go to work.